So let's take another look at this question and start by looking at these apples. Now these apples are roughly the same size and roughly the same shape. They're made up of all of the same parts and all of the same pieces, the same chemicals, same everything. Let's see what happens when I take their mass though. So this first apple has a mass of 141.73 grams. And when I switch it out and I take the mass of a very similar apple, it has a mass of 150.38 grams, despite the fact that they're both made up of the same things. Isotopes are very similar. Now, isotopes are very similar to this because isotopes are made up of the same things. That is to say that they are the same element. Now, the same element means that they have the same number of protons, okay? So we're going to look at the element carbon. Carbon has 6 protons, and every single carbon atom will have 6 protons. If you change the number of protons that you have, you will change the element that you're working with, okay? And carbon in its most abundant form normally has 6 neutrons as well. So we'll change the color, and we will put 6 neutrons in here as well. And normally it's also surrounded by all its electrons. But when carbon is in this state, with 6 protons and 6 neutrons, we say that we have the isotope carbon-12. Because what an isotope is an element with the same number of protons, but a different number of neutrons. So if I were to draw carbon again with 6 protons, but instead of 6 neutrons, this time I'm going to do 7 neutrons. I would still have carbon because I have not changed my number of protons, but now I have a new carbon isotope. I have carbon with 6 protons and with 7 neutrons. So instead of the isotope carbon-12, I have the isotope carbon-13. So just in the way that our apples were very similar in size and made up of all the same things, isotopes are made up of the same number of protons, but a different number of neutrons, so they have a different mass. Let me know if you have any questions.